Hello, so my name is Sadie Shelton, and today is April 8th, 2021. And for my for my reproductive portfolio presentation, I will be talking about the determination of gender, genes versus hormones. So, of course, we know there are two genders, male and female, and there are a bunch of different genes and hormones and processes that happen when we're really, really little embryos and fetuses that help determine whether or not we will be male or female. And before we start and get into any of that, we first have to talk about chromosomes. So in the human body, we have 23 pairs of chromosomes. Every single cell has 23 pairs of chromosomes. They hold all of our DNA, they hold all of the genes, they are the genetic makeup of who we are. And as we can tell in this picture, there are 22 pairs of what are called autosomes. These have nothing to do with gender. The one pair that does are the sex chromosomes, and those we each get one sex chromosome from our mother, and we get one sex chromosome from our father, and those put together are what helps determine the genetic makeup of whether we are male or female. So sperm or males, sperm come from males, so males are X, Y. Those are the sex chromosomes of a male. Females, the sex chromosomes they have are X and X. Now, who do we get from what, and how does that determine whether we're male or female? So for females to become female, your sperm is going to have the X sex chromosome, and of course the women can only give X. So in both cases, the egg is going to have the X sex chromosome. It's more determined upon the male whether they have the sperm is X or Y. So if we have an X carrying sperm and an X egg cell, then our sex chromosomes are XX, and that means you're going to have a girl. On the other hand, if you have, of course, the egg cell is always going to give X, and then the sperm gives Y, your sex chromosomes are going to be XY, and that means you're going to be a boy. So that's kind of like the first step, whether you have XX or XY. The next step is another gene called the SRY gene. So when we have, of course, XY, so we have a male, the zygote is XY, as we can see here. This zygote is going to have the SRY gene. And the SRY gene stands for the sex determination region Y gene. If the zygote is XY and has the SRY gene, then these embryonic gonads, which when you're really little are in a state where it can go either way. They can either determine into, they can grow into testes or ovaries. They can grow male or female sex gonads. And it all kind of depends on the chromosome composition of the zygote and whether or not they have the SRY gene. So if we have XY and we have the SRY gene, then these embryonic gonads are going to turn into testes or testicles, and you're going to have testosterone, male. On the other hand, of course, as we determined earlier, the zygote is XX, so already female. Females do not have the SRY gene, so no SRY gene. That means these embryonic gonads are going to turn into ovaries, which produce estrogen, the hormones estrogen and progesterone, female. So with the SRY gene, that's just kind of a recap. If you have it, you're going to develop testes. If you don't have the SRY gene, these embryonic gonads are going to turn into ovaries. So as I mentioned a little bit earlier, with this embryonic gonad, when the fetus or embryo is about 6 weeks old, it's called the bipotential stage. So bi means two, so you have two potentials. These ducts and gonads can go either way. They can turn into testicles or they can turn into ovaries, and of course it has to do with hormones and genes. So as we can see here, of course, male or female, you're always going to have two kidneys. This cloacal opening will eventually turn into the anus and attach to the digestive system. What we're mostly looking at is this bipotential gonad and this Mullerian duct and the Wolffian duct. So this bipotential gonad will either turn into a testicle or an ovary, and then either one of these ducts will live and one of these ducts will basically die off. And that's kind of another way to determine whether or not it will be male or female. And we'll go into that next. So female differentiation. So we're going to kind of run back to the beginning. So we already know the zygote is XX. Got X from the sperm, X from the egg, and we do not have the SRY gene. No SRY gene, your bipotential gonad is going to turn into an ovary. Another thing that with no SRY gene, we have no testosterone. So no testosterone means that this Wolffian duct is going to degenerate. It's going to shrivel up. It's not going to grow. It's not going to turn into anything. So what's going to flourish is this Mullering duct. Another thing that's important with testosterone and the testes is the testes also produces a hormone called the anti-Mullering hormone. So if we don't produce this anti-Mullering hormone, then the Mullering duct is going to be allowed to grow and proliferate and turn into, allows the Mullering duct to become the fallopian tube, uterus, and upper part of the vagina. So kind of as a big recap for female differentiation, you're going to start with the sex chromosomes. You're going to get an X from the sperm. You're going to get an X from the egg. This XX zygote is going to have no SRY gene, and so your bipotential gonad is going to turn into an ovary. When you have an ovary, of course, that means it's not a testicle, so you're not producing testosterone and you're not producing anti-Mullering hormone. So your Wolffian duct is going to degenerate and your Mullering duct is going to grow into the fallopian tube, the uterus, and the upper part of the vagina. And that's kind of all of the pieces that help with female differentiation. So next, we're going to talk about male differentiation. So as we talked about previously, you are going to have X sex chromosome from the mother and Y sex chromosome from the sperm. This XY zygote is going to produce the SRY protein. This SRY protein is going to produce a testicle. Testicles do produce testosterone. And so that's going to help determine whether or not your Wolffian duct degenerates or your Mullerian duct grows or degenerates. So as we can follow in this flowchart, the SRY protein in a male embryo, you're going to have your bipotential gonad turns into a testicle and not an ovary. Because you have a testicle, you're going to produce testosterone and anti-Mullering hormone. And of course, anti means no. So your Mullering duct is going to go away. Not going to grow, not going to turn into anything. And in this case, your Wolffian duct is the duct that is going to grow and turn into male sex organs and characteristics. So testosterone from the testicle converts your Wolffian duct into the seminal vesicle, the vas deferens, and the epididymis. And then, of course, DHT is a precursor of testosterone, and this helps controls the prostate. And so as a recap, with male differentiation, you have X chromosome from the mom in the egg, Y chromosome from the dad from the sperm. So you have XY zygote. This XY zygote is going to produce the SRY protein. This is going to turn your bipotential gonad, that can either turn male or female depending on whether or not you have the SRY gene. In this case, we do have it, so it is going to turn into a testicle. Testicles produce a couple of different hormones. They do produce anti-Mullering hormone. So when you have the two ducts, the Mullering duct and the Wolffian duct, whether or not you're going to become male or female determines which one grows and which ones degenerates. And so in the males, you have the testicle, which produces anti-Mullering hormone, so your Mullering duct is going to degenerate and not grow into anything. Testosterone from the testicle converts the Wolffian duct is what helps the Wolffian duct grow. So your anti-Mullering hormone causes the Mullering duct to shrink, and then the testosterone converts the Wolffian duct into those male organs and sex characteristics. And that is how genes and hormones help determine the gender of a baby when it is really, really small.